Hello, my name is Taylor Foote, and welcome to my presentation about photochemical smog. The term smog originated back in the early 1900s, a combination of the words smoke and fog, which describes its physical appearance perfectly. Back then, the smog they were referring to was sulfurous smog, or more commonly known as London smog, formed when there are high concentrations of sulfuric oxides in the air burning from coal. This type of smog was a major issue about a century ago, and in some areas still is. But in today's world, we struggle with the second type of smog, which we will be studying today, photochemical smog. Photochemical smog is an air pollutant created through a complicated series of chemical reactions between nitrogen dioxide and hydrocarbons when they are exposed to ultraviolet radiation. Smog is made up of many different pollutants, two of the biggest being PANs and ozone. There is not a single chemical equation to explain it, but a complex process as to how it's formed. Part 1. The exhaust from our cars gives off nitrogen dioxide that is then photolyzed by ultraviolet radiation from the sun. That decomposes nitrogen dioxide into nitrogen oxide and one radical oxygen atom. We don't see that often because oxygen is a diatomic element. The air around us is almost entirely made up of nitrogen and oxygen, so that radical oxygen reacts with other oxygens in the atmosphere to create ozone, O3. In normal conditions, the nitrogen oxide will react with the ozone and produce oxygen and nitrogen dioxide. This cycle only leads to temporary increases in net ozone production until volatile organic compounds, or VOCs, come into play. To create large-scale photochemical smog, VOCs must be included in this process. Part 2. Hydroxides in the atmosphere react with VOCs to produce water and a reactive VOC molecule. That reactive VOC can then bond with an oxygen molecule to create a synthesis reaction producing an oxidized VOC. Going back to the last set of equations, the product nitrogen oxide can now bond with the oxidized VOC to produce nitrogen dioxide and a reactive VOC molecule. To sum it up, in the final set of equations, we see that nitrogen oxide produced in the first part is oxidized without destroying any ozone. So when VOCs are present, equation 3 is almost eliminated, which leads to a large buildup of photochemical smog in our atmosphere. How frequently does this chemical process actually happen? Well, every day. This chemical process occurs daily and can happen in both urban and rural environments, but the severity depends on the geographic location and the time of day. Let's say it's a sunny Monday morning in the city. Everyone is driving to work or school and filling up their gas tanks. At this time of day, the concentration levels of nitrogen oxide in VOCs are high. By mid-morning, the nitrogen oxide starts to oxidize, which reduces its concentration in the atmosphere. Nitrogen dioxide concentration peaks around midday, right before the solar radiation is strong enough to photolyze the nitrogen dioxide, releasing the rogue oxygen to quickly bond with another oxygen molecule to create ozone. Late afternoon is when you'll see the highest concentration of photochemical smog. Smog is a year-round problem, but in areas that see extreme seasonal change, it is more problematic in the summer months. Geographic location also plays a role. Obviously, a busy city will see more smog than the countryside, but cities and towns located in mountainous regions or basins see more smog than others because the wind cannot carry out the smog, leaving it trapped in the valley. Two examples you can see here are Mexico City and Los Angeles. You see where the smog sits and where the mountains are above in the background of the pictures. Cities and towns with more green spaces or year-round wind and rain will experience less severe smog. Photochemical smog consists of both primary air pollutants and secondary air pollutants, which means it can be very hazardous for our environment and ourselves. Ozone affects plant life and their abilities to grow on both large scales and small scales. So anywhere from the trees lining down your street to the big forests and crops that live outside the city lines. On the image here, you can see the progression of ozone damage on watermelon foliage. So figure A is obviously the least amount of damage, and then figure F on the bottom right is the most. Certain crops are especially susceptible to infection when exposed to smog. Some examples are vegetables, soybeans, tomatoes, wheat, and cotton. Acid rain is formed from air pollution and really harms aquatic life, which is then passed up the food chain through birds and other mammals. Animal life takes a long time to adapt to different toxins in the air, and smog inhalation can affect their immune systems. Innumerable different species have been killed or injured due to smog-related illnesses, humans being one of them. Smog can significantly damage lung tissue and can aggravate or even cause a number of health problems, including asthma, emphysema, chronic bronchitis, other respiratory issues, or even pulmonary disease. Other health-related symptoms include dry and itchy eyes or skin, and can even affect your ability to battle colds and flus. You can see in the first image how the alveoli is destroyed with emphysema, and in the second image you can see the ozone levels. When the ozone levels are high, muscles contract and the pathways for breathing are narrowed. There are a couple high-risk groups that need to be especially careful on smoggy days. People with respiratory or pulmonary diseases or infections, people that exercise outside, so sports or running, the elderly, and children. Many people don't think about children as being high risk, but they are often outside playing during school days and after hours, and asthma is the most common chronic disease for children. Smog inhalation can also cause developmental harm in children who are highly exposed. We have explored the effects of smog on our environment, but smog can have devastating economic and social effects as well. Economically speaking, smog costs money, or more specifically, its repercussions cost money. A couple of minutes ago, we talked about the loss of important crops due to smog, while the province of Ontario estimates damaged crops cost about $201 million per year. The tourism industry also sees large financial repercussions from smog, mostly due to impaired visibility of landmarks and attractions. The Government of Canada estimates that one day with highly impaired visibility can result in the loss of about $7.45 million in Vancouver tourism and $1.32 million in Fraser Valley tourism. Aside from the dollar figures in government spending, smog has smaller scale economic repercussions as well. Costs of replacing, cleaning, or upgrading houses can come more frequently with smog present because it actually is accelerating the breakdown of the materials we use for buildings. Health issues related to smog can be reflected in medical spending from treatments or hospital stays, as well as loss of worker productivity within companies or loss of pay for individuals unable to work due to smog-intensified illnesses. Social and economic impacts often come hand in hand. I'm sure you can link some social impacts from smog related with tourism or the social impacts of missing work, but there are a couple more social factors to consider when studying the effects of smog. The obvious one being isolation. When smoggy days are among us, not only the high-risk groups stay inside. In the past, we have seen large-scale lockdowns due to smog. For example, December 2015, Beijing called a public state of emergency and a citywide lockdown as they stated their first red alert for air pollution, with a second one following only weeks later. Students were online, workers were at home with no pay, and people sitting anxiously at home waiting for what's next. Jackson Liu, an assistant professor at MIT, warns that smog has obvious effects on our physiological health, but can also lead to negative psychological effects. The stress from health-related problems, loss of jobs, or unsure future can trigger anxieties and depressions. Systematic inflammation caused by these anxieties also intensifies these anxieties. It's a vicious cycle. Studies in China have shown smog effects on cognitive functioning throughout school-aged kids, with increased exposure leading to a negative post-secondary attainment and earnings over time. Air pollutants can also lead to cognitive disorders like ADHD or dementia. Research surrounding that shows that people who live in areas with excessive amounts of particulate matter have a higher risk of getting dementia by 92%. Your mental health is very important when it comes to social aspects of your life and the relationships you have with your family, friends, and coworkers. It also affects your ability to react accordingly in social situations. The average person has heard of smog before. Some even know the extensive effects it has on humans and our environment. But not enough people are aware of the devastating impacts air pollution could have on the future of humanity if not controlled. Since different red alert air quality scares, many countries and regions have implemented their own laws and regulations to minimize the effect of air pollution. For example, in 2016, Canada introduced Pan-Canadian Framework on Clean Growth and Climate Change. Scientists who study this topic are actively looking for new environmentally sustainable ways to create and preserve energy, and also new ideas to clean the air. A company named Airconic has created a concept for a 3-mile-high self-cleaning skyscraper that also cleans the air around it. And there are many more companies creating concepts with similar outcomes. Some of these ideas include photosynthesis bikes, giant skyscrapers with sprinklers on them, cloud seeding, air purifying billboards, and many more are unraveling every day. We have already seen air quality ratings globally improve throughout summer 2020 following an almost worldwide lockdown due to COVID-19. People were staying home from work, school, and regular outings. Cars were parked, factories quiet, and my drive to work in the morning was a breeze. But that obviously didn't last long. But it did last long enough for me to make the observation driving south on the 404, wow, there's no smog bubble over Toronto today. Or this picture here of New Delhi before and after lockdown. Soon enough, everyone was back to the hustle and bustle of modified everyday life, and unfortunately for our environment, doing the bare minimum just isn't enough. We put the world on pause for a life-threatening virus, but what about the life-threatening long-term effects of air pollution on humans and the environment we require to survive? Thank you for listening to my presentation on photochemical smog. Have a great day.